Okay, so moving on with limits with infinity. If I plug in infinity, I'd get infinity minus infinity. That is an indeterminate form. That means nothing, so I need to do some algebra. So I am going to take this, and we've done this many times before. I am going to multiply by the conjugate. So conjugates come up when you need to do algebra, and lots of times they come up when you see radicals. So let's just do it. X plus x squared plus 2x. Okay, so carrying the limit along every time while we're doing these. So in the numerator, I get x squared minus x squared plus 2x all over this. Okay, so I see the x squared's canceling. So I get a negative 2x over x plus the square root of x plus 2x. Okay, so here, this is a nice challenging one. So I need to go in and take the highest powers. So the highest powered term from the numerator is negative 2x. The highest powered term on the denominator is this x and this. This is almost like an x because it's like a square root of x squared. All right, so what that turns into, negative 2x, x plus the square root of x squared. Okay, so I have to do something with this, and I did mention something, I think first day of class, the fact that you need to know that this is equal to this. So let's replace that. Limit as x goes to infinity, negative 2x over x plus absolute value of x. Okay, also on the first day of class, I talked about this definition of absolute value. So this absolute value, if I have a positive number in there, I just get positive x out. Well, I am going to positive infinity. So since I'm going to positive infinity, I can say the absolute value of x is x. So then, joining these in the denominator together, canceling the x's and the 2's, I get negative 1 as the answer. Whew, that was challenging. Okay, so I've got a couple more. So notice they're the same problem with the positive and a negative infinity, and I've got this radical with an x squared. So this thing is going to keep coming up. So stretching us a little bit. Okay. So let's go through and pick the highest powered terms from the top and the bottom, right? To take limit towards infinity. So this would give me 3, right? Root 9 is 3, the square root of x squared over 2x. So I need you to show me the step that you're replacing the square root of x squared with the absolute value of x. Then I need you to show me the step, because you're showing me with mathematics, right? You're being mathematicians. If I'm taking the limit as x goes towards infinity, this will give me x. Cancel the x's, so I get 3 halves. This is the same problem, only I'm going towards negative infinity. So limit as x goes towards negative infinity, so this would give me 3 absolute value of x over 2x, right? Just because I just did it up here, don't need to repeat every single step. I do need you to show me, okay, I'm plugging in, whoops, let me write that again. I'm taking the limit as x goes to negative infinity. So remember, the way the absolute value works is it takes the opposite of a negative number. That's how it makes it positive. So these will be negative numbers in here because I'm going towards negative infinity. So I'm going to replace the absolute value of x with negative x because that's what makes it positive. So now I can cancel the x's, so I get negative 3 halves. That's tricky. Okay, so how is it we find vertical asymptotes? You knew this before we met. First, you must cancel any factors, right? Because those make holes. We've been doing those all along, right? The lines with the holes in them. Then you look to see what numbers make the denominator 0, and that if that's a x value, so that x equal a makes a vertical asymptote. Horizontal asymptotes, you're taking the limit as x goes towards positive and negative infinity. Remember, when you're in finite land, right, when you're in this kind of area here, you could cross your horizontal asymptotes. Horizontal asymptotes are called end behavior. What's happening as you're moving towards positive or negative infinity, right? So you could have something like this where it crosses a horizontal asymptote in little finite land in here, but just lands on heading out to some y value, positive and negative. You never cross a vertical asymptote. All right, so let's go looking for something like this. All right, so for any of these, I want to make sure I'm canceling first. So I'm going to factor what I can. So x minus 5, x minus 1. So this numerator can factor some more. See difference of squares. X minus 5, x plus 1. Okay, so I see these x plus 1s cancel. So what I'm left with is this function is x times x minus 1 over x minus 5. Okay, so there's a hole there, right, at x equal negative 1. So I'm not going to look at that. I'm just going to look to see what's left over. So I can see there's going to be a vertical asymptote at x equal 5 because that makes the denominator 0 but not the numerator. To find the horizontal asymptotes, I'm going to take the limit as x goes to infinity, and then I'll take the limit as x goes to negative infinity. That's how we find horizontal asymptotes. So with infinities, again, we take highest powers. So limit as x goes to infinity. So I would get x squared over x. That gives me infinity. And I do the same thing with the negative infinity. I get x squared over x. That gives me negative infinity. So what that means is that there are no horizontal asymptotes. The end behavior does not go towards any one y value.